Assalamu alaikum wa rahmatullahi wa barakatuh. Inshallah, we're going to start with chapter 13, parent function and function analysis. And during this chapter, I'm going to cover different topics regarding the function. How can you analyze a function in a graph? How do you know which function that you are dealing with from the graph? Let me give you a simple breakdown over the type of discontinuity. The first one is the removable. Removable means that you're going to cancel one of the factor. What is the meaning of this? For example, you have here x power 2 minus 4 over x minus 2. If you factorize the first one here, or the numerator, give you x minus 2 times x plus 2 over x minus 2. As you noticed here, I'm going to cancel one of the factors. So if you cancel one of the factors here, this means that you have a removable discontinuity and you have a whole. Another type, we have the infinite discontinuity. This, you have it when you cannot cancel any factor. For example, here, x plus 2 over x plus 4. I cannot cancel any factors. This means I have infinite discontinuity. So you have it when you have a rational function and you cannot cancel. And you have a vertical asymptote. The vertical asymptote is the number which makes the denominator equal to 0 because we cannot divide by 0. So here I have a vertical asymptote at x equal to negative 4. Now, also we have jump discontinuity. We have the jump discontinuity when you have a piecewise function, which means that you have a function from two parts, like this one. So this means that you have to check the endpoints. So if they are equal, so there is nothing. But if they are not equal, so this means we have a jump discontinuity. For example, function of x equal x plus 2 when x is smaller than 2, and 5 when x equal 2, and x minus 1 when x is greater than 2. Let me try to substitute the 2 here. If I substituted the 2 here, it gives me 4. And if I substituted the 2 here, it gives me 1. So I examine my function from left and right, and they are not equal. So this means I have a jump discontinuity here. 1 to 4. Okay, here we have question 30. Which type of discontinuity you have? Let me factorize this one first. It's x minus 1 times x plus 1 over x minus 1. I could cancel. So this means I have, cancel this one. If I could cancel a factor, this means I have a removable discontinuity. So choice D. Now, question 31, which type of discontinuity does the function have? Okay, I cannot cancel any factor, and there is no piecewise function here to give a jump discontinuity, but I have a vertical asymptote in a rational function I cannot cancel, so this means it's infinite discontinuity. Question 32, what value of a makes a function continuous? Continuous means that the limit from left equal to the limit from right. So let me first factorize the first part here, x power 2 minus 16 over x minus 4. If I factorize it, it would be x minus 4 times x plus 4 over x minus 4. So factors, so it would be x plus 4. Now, if I substituted the x with 4, it gives me 8. So the limit when x approaches 4 from left or right, whatever, consider it from left. So it would be give me 8. So this means that a could be 8. So the function would be continuous. Question 33 is a type of discontinuity of the function. Okay, here we have piecewise function, right? But let me check first the limit. So if I substituted here 1 minus 1, it gives me 0. If I substitute here 2 times 1 give me 2 plus 1 give me 3. So 0 and 3. So we have jump from 0 to 3. This means this is a jump discontinuity. Okay, question 34 is asking you the function is not continuous at x equal negative 1. So if you check here at x equal negative 1, you have a vertical asymptote. So once you have a vertical asymptote, and you cannot cancel any factors, this means it's a infinite discontinuity. Which of the following function is continuous but has a removable discontinuity? The removable discontinuity means I have to cancel factor. So, of course, it's the first answer, but let me check the other choices here. This is infinite one. The x cannot be here, x equal to 1, so it would be 0. It's okay, nothing. It's continuous. For this one, it's also infinite because we have a vertical asymptote. So the only choice here I have x power 2 minus 1 over x minus 1. Because if I factorize it, it would be x minus 1 times x plus 1 over x minus 1. So I'm going to cancel this factor. Question 36, the point of discontinuity of the function. Now we have here infinite discontinuity. Once we have infinite discontinuity, this means we have to get the vertical asymptote. How we get the vertical asymptote? Put the denominator equal to 0. So here, x power 2 minus 5x plus 6 equal to 0, then factorize. So it would be x minus 6 times x plus 1 equal to 0. So maybe x equal, it's right here, my mistake, x minus 2 times x minus 3 equal to 0. So x equal 2 and x equal 3. So here I have x equal 2 and 3 as the vertical asymptote. Now, which of the following graph represent a function with jump discontinuity? As you see here, this one is infinite. You're going to infinity, and here you're going to negative infinity. So this is infinite discontinuity. Here we have a hole, so this is removable. Here, this is a continuous function. Okay, so this one is jump discontinuity. As you see here, the y value have a jump from 2 to 1, negative 2 to 1. Another concept that you have to know, intermediate value theorem. The intermediate value theorem states that if your function is continuous over an interval of time or interval of numbers, this means that if you substitute these numbers, which are x, yani, in the function, and you got value that are opposite in sign or different in sign, this means there is x-intercept or zeros between them. Let me explain this in number to understand it more. For example, if you have function of x equal x power 2 minus 4 and it's continuous over the interval 1 and 3. Let me substitute. Function of 1 give you negative 3 and function of 3 give you 5. As you see, different sign. So this means between 1 and 3 there is an answer or solution for the function or 0. Okay, good. Now another thing that you have to know is the end behavior of the function. It's very easy. The end behavior of the function means I'm gonna describe the graph is looking up or down, or both of them in the same direction, or both of them is not in the same direction. Okay, so let me start first with the even one. Even degree means that the greatest power that you have in the polynomial function is even, and you have something called the leading coefficient. Let me explain this. For example, I have here 3x power 4 plus x power 2. Okay, now this is the greatest power, it's even. And you have a number besides the x here. We call it the leading coefficient. If it's greater than 0, this means that both of them is looking up. What is the meaning of looking up? They're going for positive infinity. So if x is negative, the y would be positive. If x is positive, the y would be also positive. As you see here, if x is negative, the y would be positive. If x is positive, the y would be also positive. Now, if your leading coefficient is negative, for example, or smaller than 0, negative 3x power 4, this means that both of them is looking down. So this means if your x is negative, your y is negative. If your x is positive, your y also is negative. So as you see, if x is negative, the y is negative. If x is positive, the y also is negative. Now going for the odd degree, odd means that you have the greatest power is odd, like 3, 5, and so on. Let me take an example here. I have x power 3 plus x. And if you don't have a number besides x, this means it's 1. Okay? And 1, of course, is greater than 0. So this means that one of them is looking up and one of them is looking down. But in this case, when you start from left, down to up, down to up. This means if your x is negative, your y also would be negative. And if your x is positive, your y also is positive. So as you see here, if x is positive, the y would be positive. Now here, if x is negative, the y would be negative. Now, if your leading coefficient is negative or smaller than 0, it would be from up to down. Again, pay attention. While we're describing in a graph, you have to describe it from left. So from left to right, this is up, then down. So this means if your x is negative, this means that your y is positive. So here, if x is negative, the y is positive. Now, if your x is negative, if your x is positive, the y is negative. If your x is positive, the y is negative. And the y is the function of x. Okay, I hope this made it clear for you. Question 38. If function of x equal x power 3 minus 2x plus 1, which of the following interval contains a 0 of the function? So this means I'm checking for interval. When I substitute it, there is a sign change. So let me check the first one here. If I substitute it with 0, it give me 1. If I substitute it with 1, it give me 0. So no sign change. If I substitute it with 1 here, it give me 0 again. If I substitute with 2, it give me, this is 8 minus 4. So again, there is a 0, so no sign change. Let me check negative 2. Negative 2 give me, this is negative 8. Negative 8 plus 4 plus 1 give me negative 3. So if I substitute with negative 2, give me negative 3. And if I substitute it with negative 1, it give me negative 1 plus 2, it give me 2. So yes, there is a change in sign from negative 3 to 2. So this means this is my answer. Which two consecutive intervals contain real zeros of the function? Again, I need a change of sign, so I'm gonna try. So let's substitute here negative 3. Negative 3 power 3 give me negative 27. Negative 4 times negative 3 give me 12. And 2. So give me here negative 13. And for negative 2, if I substitute it with me negative 8. Negative 8, 4 times 8 give me 8 also. So it's positive 8 plus 2. So it give me 2. So yes, there is a change here. Let me try the 0 and 1. So if I substitute it with 0, it give me 2. If I substitute it with 1, 1 minus 4 give me negative 3. Negative 3 plus 2 give me negative 1. So yes, there is a change in the sign. So yes, the first interval here would be the answer. The graph of the polynomial function is shown. Which of the following correctly describe the left end behavior? So I have to describe this part. When x is negative, the y is positive, or the function of x is positive, or it go for infinity. So here's the answer. Now, what is the behavior of the function? Function of x equal to x over x power 2 plus 1. When x approaches infinity or goes for infinity. Do you remember the rules for the limit at infinity? When this is x power 1 and this is x power 2. When the numerator is smaller than the denominator, all the time the answer would be 0. So this means it's equal to 0. Now we're gonna discuss how the function is increasing, decreasing, or it's a constant. Okay, now it's increasing if you are increasing the x and the y value also increase. For example, if I put function of x equals x plus 1. Now let's see, if I put x was 1, y is 2. If I put x was 2, y is 3. If I put x was 3, y is 4. So as the x increase, y increase. Okay, decreasing, if x is increasing, y decrease. Let me give you another example. X equal negative 2x plus 5. If I put x was 1, y, negative 2 times 1 give me negative 2 plus 5 give me 3. If I put x was 2, negative 2 times 2 is negative 4. Negative 4 plus 1 give me 1. So as you see here, x is increasing and y is decreasing. So this is a decreasing function here. Okay, now constant mean while increasing x, the y is still the same. So it would be like this. So as x equal 1, y 2. As x equal 2, y still is 2. As x equals 3, y is still 2. This is a constant function. So here, this means that you are increasing, this means that you are decreasing, and this means that you are constant. Now, as you see here, there's a graph here. The graph starts from negative 4 to 4. So I need you to express the interval where the function is increasing and decreasing. As you see here, it's decreasing from where to where? From negative 4 to 0. While expressing the interval, you have to make it open. So it's decreasing from negative 4 to 0. Then it's increasing from 0 to 4. Knowing that the function is increasing or decreasing, you have to know what is the meaning of absolute minimum, absolute maximum, local maximum, and local minimum. Okay, the meaning of absolute maximum means the highest point or the highest y value. Absolute minimum, it's the lowest point, and local or relative, the same meaning. Local maximum means the highest point over interval, specific interval. And the same for local minimum, the lowest point over a specific interval. So let's see here. Where is the lowest point on the graph here? This is the lowest point. So for me, this is absolute minimum. Where is the highest point on the graph? The highest point on the graph is here. So this is the absolute maximum. What about this one? This is local maximum. This is also local maximum. This is local minimum. Also, this is local minimum. Maximum mean, and you have to know this, maximum mean that you are changing from increasing to decreasing. So increase to decrease. And minimum means from decrease to increase. Okay, so again, I'm increasing here. This is increase, then decrease. Increase, then decrease. Now you are changing from decreasing to increasing. This is a local minimum. So again, if you are changing from increasing to decreasing, this is a maximum. If you are changing from decreasing to increasing, this is minimum. The average rate or the average speed is the slope of the secant line. What is the meaning of secant line? Secant line means a line cut your graph at 2 points. For example, you have a car and your car is not moving on a straight motion, it's moving on a curved path, and you need to know the distance. You need to know the speed. So at this time, we're gonna calculate the average speed. So I am gonna draw a line passing by the curve at 2 points and get the average speed. If I got the slope, this is the average speed. So what is the slope or what is the average speed? It would be function of p minus function of a over p minus a. For example, let me give an example here. I have function of t equal 5t squared. And I need to calculate the average speed. This is over interval, let's see, from 0 to 2. So I'm going to substitute the 2 first. So 5 times 2 bar 2. 5 times 4 is 20. And 5 times 0 bar 2 give me 0. Now let me apply the rule here. It would be 20 minus 0 over 5 over 2 minus 0. So 20 divided by 2 give me 10 meter per second squared. Sorry, meter per second. This is the speed, not acceleration. Which of the following best describes the behavior of the function here? When x is negative, the y is negative also, but we have end for this point, which is 2. So when x go to negative infinity, the function of x equal to 2. Okay, now when x is positive or x go to positive infinity, I read the value at y equal 5. So the function of x equal to 5. We call this horizontal asymptote. Remember the meaning of asymptote? Asymptote aligns that the graph does not touch it, but get closer and closer to it. So the answer here is, this is negative 2, sorry. So the answer here, when x approaches negative infinity, the g of x equal negative 2, and when x approaches infinity, the g of x equal to 5. In the adjacent graph, the function is decreasing over the interval. Decreasing mean when x increase, y decrease. So where is the interval where when x increase, y decrease? As x increase from 1 to 3, from 1 to 2, the y decrease from negative 1, negative 2, negative 3, and negative 4. So from this interval, from 0 to 2. If the function of x is defined over the interval from 0 to 10, and it's increasing from 0 to 4, and then decreasing from 4 to 6, then increasing again on 6 to 10. So then the function of x has a local maximum. Local maximum mean that you are changing from increasing to decreasing. So where your function is changing from increasing to decreasing at 4. Okay. Now, question 45 from the adjacent graph, what is the absolute maximum value? Absolute maximum value means the highest point on the graph. This is the highest point at 3 and 1, 2, 3, 4, 5, 6, 7, 8, and 9. So this is at 3 and 9. So the y value here would be 9. The adjacent graph classify point B. Where is B here? B is here, local maximum. Okay, question 47 in the adjacent graph. On the interval a to b, the function of c represent, here, this one, represent what? A local maximum also. From the graph of the function of x, at which does the function of x attain absolute minimum value? Absolute means the lowest point on the curve. Where's the lowest point here? At 3 and negative 12. Find the average rate of a change of the function. Remember the rule of the average change? Function of p minus function of a over p minus a. This is a and this is b. So let's substitute first 1 and 4. If I substituted 4, 3 times 16 minus 4 plus 1. So here is 45, and 3 times 16 is 48. 48 minus 4 is 44. 44 plus 1, 45. Now 3 times 1, 3. 3 minus 1, 2. 2 plus 1 give me 3. So 45 minus 3 over 4 minus 1. So 45 minus 3 give me 42. 42 over 3 give me 14. So the answer here is 14. A body moves along a path with position given by s of t equal 5t squared. Find its average speed. As you remember again, this is the rule for the average rate or the average speed. So let's apply it. I'll substitute first with 3. It would be 45. Substitute it with 1. So it would be 5. So 45 minus 5 over 3 minus 1 give me 40 over 2 give me 20. Here is the part of the parent function. These are the parent functions that we do most of the transformations on it. You have to know the shape and the symbol for it. Okay, so this is the constant function of x, for example, function of x equals 3. This is the linear function of x equal x. Okay, here's the absolute value. Function of x equals the absolute value of x. The quadratic, this is the shape of it, the parabola. This is V shape. This is like Q. Function of x equal x power 2. The square root function. This is the cubic function. Function of x equal x power 3. This is the cube root function. Cube root is different from the cubic. As you see here, it's flat, more flattening than the cubic. The reciprocal or the inverse or the rational function. It has a vertical asymptote and horizontal asymptote as 0, 1 over x. Here is the rational function, but for 1 over x power 2. Here is the logarithmic. And here is the exponential. The greatest and the greatest integer function. Let me make it clear for you here. Starting from 0, here's 1, 2, 3. It would be closed circle, then open circle. And you have another step. Closed circle, open circle. Another step. Closed circle, open circle. This is the greatest integer function, and for the greatest integer function, the number should be less than or equal to the greatest, to the integer, the nearest integer. Okay, For example, if I'm taking the greatest integer for 1.2, what is the answer? It would be 1. Less than or equal. What if I'm taking the greatest integer for 2? It would be 2. What if I'm taking the greatest integer for negative 1.2? It's not negative 1. What is the smaller than negative 1? It's negative 2. So the answer should be an integer, positive or negative or 0, it doesn't matter, but have to be less than or equal to the value inside the bracket here. Okay, here is the transformation rules for the function. And I'm going to apply all of these transformation over the quadratic function for you to understand. Let me give you some points here. Vertical means that you are moving along the y-axis. You're moving up or down. Horizontal means that you are moving right or left. Okay, good. So if you are moving up, so it's positive. If you are moving down, it's negative. But for the horizontal, you're gonna switch. If you are moving to the right, it's negative. If you are moving to the left, it's positive. And when I say vertical, this means that you are doing the transformation for the whole function. Okay? When I say horizontal, this means that you are doing your changes to the x itself. So let me make it clear for you. Here, function of x equal x power 2. Now, if I'm telling you, here is the parent function. You are moving up 3 units. So it would be like this. Function of x, let me make it g of x to be different one. G of x equal x power 2 plus 3. This is a vertical translation, 3 units. So 1, 2, 3, it would be like this. I moved up 3 units. Good. Now, if I say that you have a vertical translation or you shifted down 2 units, so it would be minus. So let's mean h of x equal x power 2 minus 2. As you see here, when I add or subtract, I add it to the whole function. This is vertical. Okay, now, so if I try to draw it here, it would be like this. Negative 2, and here's 3 units, for example. Good? Good. What if I'm asking you to do a horizontal translation to left? Now, horizontal means that whatever you're gonna do, you do it for the x itself. Okay? So here, I'm gonna say you have a horizontal translation to left 2 units. So let me write it for you. Say it's m of x equal x. You're doing what? Horizontal translation to left. Left means positive. How many units? 2 over 2. So again, here, do you see the difference? I do the change to the x itself, not to the whole function. Okay? Again here. What if I'm asking you? So this is core left. What if I'm asking you do a horizontal translation to right 4 units? This means right negative. So it would be x minus 4 all to power 2. This is for the right. I could mix both, of course. I could make a horizontal translation and also a vertical translation. Let me see here. Let me draw it for you first to understand. For m of x, I shifted to left, so we here negative 2, right? Here is it. And for e of x, I shifted 4 units to the right. Here's 4. Good. As you see here, I'm just changing the vertex. The vertex was 0 and 0. Here it would be -2 and 0. Here it would be 4 and 0. Now let's try pose. Vertical and horizontal. This is the big function. Now I'm giving you a graph and I'm telling you, here is my new graph. Now here, the vertex was 0 and 0. Now the vertex is 4 and 2. You moved how many steps on the x-axis? 4. To the right or the left? To the right, so it would be -4. And you moved how many steps along the y-axis? 2 units. Up or down? It's up, so it have to be +2. Now, how could I write my function? So let's see. G of x equal. Good. So here's the x. You make an horizontal, so this means that you are adding or subtracting to the x itself. Here is it. Then you do vertical, so this means that you're doing it for the whole function. So it would be +2. Here's my function. Okay, good. Another type of function, we have the reflection. Now, for the reflection, this means that you flipped your graph like this. So this means I have to put a negative sign to the whole function if you are flipping it through the x-axis. Now, if you are flipping it along to the y-axis, let me give you another example here. This is the cubic function, right? Good. Now, if you flipped it along to the y-axis, it would be like this. So this means instead of x, you have to put -x. This is function of x equal to x power 3, right? If I want to write it, it would be function of x equal, sorry, g of x. Instead of the x here, I'm going to put -x all to power 3. This is a reflection over the y-axis. And this is a reflection over the x-axis. Okay, then we have the stretch and the compression. Stretch and compression means that you are making a shrinking or enlargement for your function. So if you are doing vertical stretch, this means that you are multiplying the whole function by a number greater than 1. For example, it would be like this. G of x equal 2x power 2. So this is a vertical stretch. Now, if you are doing a vertical compression, you're gonna multiply your whole function by a number between 0 and 1, which means it's a fraction. Okay, here, g of, let's say it's h of x equal 1 over 2x power 2. This is vertical compression. Okay, now let's go for the horizontal. The horizontal means that you are doing whatever you do to the x itself. So you're going to multiply to x, right? Now, if you are multiplying to x by a number greater than 1, so it would be a horizontal compression. Let me see, give you this one. So let me see that m of x equal half, no, 2x all to power 2. I multiplied the x itself, so this by a number greater than 1, so this is a horizontal compression. What if I do this? I multiplied the x itself by a number between 0 and 1, which means it's a fraction. So this means it would be a horizontal stretch. So let me summarize it for you. If you are multiplying by a number greater than 1, so yeah, it may be vertical stretch or a horizontal compression. But I have to check which I have multiplied, the x itself or the whole function. If it's the whole function, so it's vertical stretch. If I multiply the x itself, so it's a horizontal compression. Okay, now if I multiply it by a number smaller than 1, between 0 and 1, or a fraction, this means it's maybe a vertical compression or horizontal stretch. Why I have to check which number I multiply to it. I multiply to the whole function or multiply to the x itself. If you multiply to the whole function, so this is vertical compression. If you multiply to the x itself, so it's a horizontal stretch. Okay, now we have a general equation for the transformation. Here's to summarize for you all of the transformation. Here, y equal the negative a function of negative x positive or minus h positive or minus k. The negative here for the friction over the x-axis. Okay, now if I multiply the a here, it's for the vertical stretch or the vertical compression. If you multiply by a number greater than 1, so it's vertical stretch. If you multiply by a fraction, so it's vertical compression. Now, when you put the negative for the x itself, so it's a reflection over the y-axis. When you add h, or you add a number, this means that you have a horizontal shift to the left. When you subtract a number, this means that you have a horizontal shift to the right. Again, horizontal, you subtract or add to the x itself. Okay, now, if you add a number to the whole function, so it would be a vertical shift upward. If you subtract, so it's a vertical shift downward. This is for you to summarize all of the transformation. Okay, the absolute value transformation, the last part in the transformation. Sometimes you have the absolute value over the whole function. For example, here, x power 2 minus 4. Okay, so if you have in a graph like this, and the absolute value over the whole function, you're gonna shift the below part on the x-axis above. So this is the original function, right? Here. Now you're gonna erase this part and shift it up. If you notice something here, there was -8 as y-intercept, right? So when I shift it up, I still have 8 as y-intercept. So I'm just flipping all of the sign. What if I'm having the absolute value over the x itself? For example, you have something like this. So this is my graph. So I'm gonna erase the left part from the y-axis and reflect whatever you have on the right. So here is your graph now. So the most common here is this one in your questions. Which of the following is the parent function? As you remember, this is the parent function for the square roots. It was like this. So it's a square root function. Which of the following is the parent function? This is a rational function here. So this one is a rational function. 1 over x. Okay, for question 53. Okay, good. This is the absolute value function. You remember this was the shape for the absolute value function. So this is the parent one. Remember, he's asking about the parent, not the transformation. Okay. If the parent function equal x power 2, and the function g of x is a transformation of function of x, shifted 3 units to left. As you see here, it shifted 3 units left. If you shifted 3 units left, this means that you are moving horizontally, making a horizontal shift. Once you're making a horizontal shift, this means that you are adding or subtracting to the x itself, right? So this means I have to say it's x minus h all to power 2. What is the h? 3. Because I'm moving to the left, so it would be positive 3. So it's x plus 3 all to power 2. If I'm moving to right, it would be x minus 3. If I were here, this one would be x minus 3 all to power 2. Now here in the graph, function of x equal x power 2, and the graph of g of x is a transformation of function of x. Okay, good. The original or parent function is supposed to be like this, right? The vertex is 0 and 0. Now let's see what happened. I moved from here to the vertex now is -2 and 4. You remember the rule? It was a times x minus h all to the power 2 plus k. Good. So here, and also here, the graph is flipped. So flipped, this means I have to put a negative sign. So it would be negative x minus k. I shifted to left or right. I shifted to left. So this means I have to put a positive sign. So positive 2 over 2. And the k here is looking. The k is the vertical shift. You go 4 units up, right? So I have to add 4. So it's negative x plus 2 all to the power 2 plus 4. So here again, I shifted 2 units to left and 4 units up. The function of x equals the greatest integer for negative 0.4 times x plus 1. Find the value of function of 3. Let me substitute first. So negative 0.4 times 3 plus 1 give me negative 1.2 plus 1. And of course, the greatest integer mean less than or equal, and it have to be integer. So what is the number, or what is the integer less than negative 1.2? It's negative 2. So negative 2 plus 1 give me negative 1. So the answer is negative 1. Okay, if function of x equals the greatest integer for the absolute value for x plus 2 plus 1, what is the range of the function? Okay, we agreed that the range for the absolute value should be greater than or equal 0, because I could take the absolute value for 0 and I could take the absolute value for positive and negative number, and the answer all the time would be positive. Good? Good. What about the integer? Okay, the greatest integer function. The greatest integer function, the answer for it may be negative, maybe positive. But I have here a restriction that I'm moving to the positive number greater than or equal to 0. So this means I have to take only the starting from 0 to positive. So I'm gonna take whatever inside the bracket here and put it equal to 0. So x equal to negative 2. So I have to start from here. So I'm gonna substitute the negative 2. Negative 2 plus 2 give me 0. 0 plus 1 equal 1. So I have to start from 1. So this means my range should start from greater than or equal to 1.
If the parent function of x equal x power 3, which of the following represent a graph that has a turning point at 2 and 1 and it's reflected over the y-axis? Okay, here, this is the original function for the x power 3, for the cubic function. As you see here, the graph is reflected over the y-axis. So instead of x, I have to put negative x. So negative x. How many units we shifted to the right? 2 units. And how many units we shifted up? 1 unit. So shifted to right mean a negative sign, so negative 2 over 3 plus 1. So here's the answer. Okay, here, which of the following graph represents a function of gx equal negative the absolute value of x plus 1 plus 2? Negative here means that you have reflection. So which graph have a reflection without any hesitation? This one. And as you see here, the vertex is -2 and 1. It matches with the equation. Which of the following graph represents a function? Here's the square root of x plus 4. We have horizontal shift to left. So this is the only one has a horizontal shift was left on 4 and there is no vertical shift. If you look to this one, there's a vertical shift also, a horizontal shift, but there's also a vertical shift with 1 unit up. So it's not matching. Okay, here, which of the following function represents a graph? Here we have a horizontal shift with 4 unit and vertical shift with 1 unit. So it would be x to the left means it's positive and vertical shift up 1 unit. So here's this one. What is the range of the function? Okay, now we know that whatever is below the root should be greater than or equal to 0, right? So I have to put this equal to 0, so 0 minus 4 equal -4, so my range starts from -4 to infinity. Now, the equation of the curve shown on the graph, okay, let me check here. Originally, this is the reciprocal function or the rational function. It was like this. We have asymptote as 0, right? And as you see here, the graph is inverted, or sorry, is reflected. So this means that I have to add a negative sign. Good. So this is my parent function. So it's what? -1. Okay. Now we have a vertical asymptote at 1. So here I have x minus 1. And we have horizontal asymptote at 2. So here is 2. So -1 over x minus 1 plus 2. What is a function that results from reflecting the absolute value function? This is the parent function. Over the y-axis. If you reflect over the y-axis, means that you have to change x to -x. 3 units left. This means that you are adding to the x. 2 units down. So here, 2 units down. Here's the answer. Okay, given function equal x power 3 and g of x equal 2x power 3. What happened here? As you see here, you multiplied the whole function by a number greater than 1. So this means this is a vertical stretch. The function of x equal x power 2 minus 3x minus 4. The g of x is the absolute value of the function. Okay, here, let me first find the root. If I factorize this one, it would be x minus 4 times x plus 1 equal to 0. So x equal 4 and x equal to -1. So basically, this was my function. It would be like this. Here is -1 and here is 4. Now, if I made the absolute value function, this means I have to remove this negative part here. So I will shift it up. So it will be like this. Where, let me check here. Yes, we have here 4. And this is -1. And I shifted it up. So here is the graph. This is the original function, 1 and 4. So it's not an answer. And here's the root, not matching the answer also. This is for a cubic one, not for a quadratic one. Okay, here, which of the following function match the graph? First, this one is quadratic function, right? Start from where? From infinity to 1, right? So x is smaller than 1. Smaller than or equal 1. Then we have constant function at 3 when x between 1 and 2, right? So 1 smaller than x smaller than or equal to 2. And I will not put the equal sign here because the whole or the open circle. Then again, I have linear function x starting from 2 to infinity, which means it's greater than 2. So when x is greater than 2, and it's not equal because this is an open circle. So which one of these match my graph here? This one. Sorry, this one. D. Now, since we have learned about function, let's do some operation on the function. We could add, we could subtract, we could multiply, we could divide, and we're gonna learn and do something here called the composite function. You're just adding or subtracting or dividing or multiplying algebraic expression as usual. So for example here, function of x equal 4x minus 5 and g of x equal to x. I'm just gonna add them. 4x minus 5 plus 2x. That's it. 4 plus 2, 6, so 6x minus 5. The same for subtraction. And the same also for multiplication and division. The things that you have to pay attention for it is the domain. And okay, you're gonna combine the domain for both function and to take care of the restriction if you are dividing. The denominator should not be equal to 0. So while you're adding or subtracting or multiplying or dividing the function, you're gonna combine the both function domain, but you have to pay attention for the restriction while you are dividing that the denominator should not be equal to 0. The most important part here is the composite function. What is the meaning of composite? A composite function is created when one function is substituted into another one. For example, here I'm telling you function of x is 3x plus 2 and g of x equal x plus 5. So if I'm gonna say if composite, you have this is an open circle. If composite g of x, this means I'm asking you to substitute the g of x inside the f. So it will be like this. Let me make it clear for you and easy. So he asked me to start with what? With the f. Where is the f? It is 3x plus 2. I need to substitute what? The g of x. So instead of this x, I'm gonna put all of the g. So let me erase the x now. So it's x plus 5. So 3 times x give me 3x. 3 times 5, 15 plus 2. So 3x plus 17. Now, what if he's asking about G composite F? Let me try to do it with you. G composite F of X mean that he's asking you to substitute the function of X inside the G. So it would be G function of X. Right. So this means I'm going to start with the G, right? Here is the G. X plus 5. Now, instead of this X, I'm going to put all of the function of X. So here's it. 3x plus 2. 3x plus 5 give me 7. So this is G composite. So again, you just erase the x and put the other function instead of it. I hope it made clear for you. Okay, function of x equal x power 2 minus 2x and g of x equal x plus 3. He's asking you to subtract these two functions. I'll just subtract x power 2 minus 2x minus x minus 3. So it would be here x power 2 minus 3x minus 3. Now here's asking F composite G. What is the meaning of F composite G? I'm gonna start with first with F, okay, because he started with F. So here's it, x power 2 minus 3. Then I'm gonna erase the x and put the g. So I'm gonna erase the x here and put the g. 2x plus 1. This is the F composite G. Now 2x power 2 give me 4x. Oh, let me just substitute to get the answer. He telling me that the x equal 1. So 2 times 1 plus 1 power 2. So it would be here 9 minus 3. 9 minus 3 give me 6. Function of x equal to x power 2 minus 5x and g of x equals 7, and he's asking you about g composite f. So this means I'm gonna replace whatever the x on the g with a function of x. But I have here 7 without any x. There is no x. So this means I cannot take a composite function, so the answer is 7. If function of x equal x power 2 minus 4 and g of x equal x plus 2, then the domain of the function f of g of x multiplied by g over f x. Let me see here. So f over g give me x power 2 minus 4 over x plus 2 multiplied by g over f. So let me get the restriction of the domain first. Here x cannot be negative 2 and x here also. If I factorize it would be x minus 2 times x plus 2. So originally x plus 2 would cancel with x plus 2 and x here cannot be 2. So I have to combine the both restriction. So x cannot be negative 2 and x cannot be 2. This one. Question 72, find the domain of the function. Okay, here. Function of x equal logarithm of the square root of 9 minus x power 2. We have to pay attention that we cannot take the logarithm for a negative number or 0. So this means this part should be greater than 0. And you know that whatever below the root should be greater than or equal to 0, right? So you have to remove the equal part. So it have to be greater than 0. Now, let me factorize. It would be 3 minus x. 3 plus x should be greater than 0. So let me check my interval. Negative 3 and 3. Again, when you have more than one answer for x, this means that you have to check the interval. So negative 4 here. This is, let me pick 2, and this is 4. Okay, good. So here, negative 4 power 2 is 16. 9 minus 16 is negative 7. So I cancel this part because it gives me a negative answer. Now, 2 power 2 give me 4. 9 minus 4 give me 5. Yes, so I am gonna take this part. Totally correct. Okay, let's pick the 4 now. Now, 9 minus 16 again give me negative 7, so I have to cancel this part. So now my domain is starting from negative 3 to 3, and it have to be open intervals because negative 3 and 3 would make my answer 0, so I have to exclude them. So it would be negative 3 and 3. This one. Good. Now for question 73 is telling you that h of x equal the square root of 2x minus 1 plus 4 if written as a composition of function of x. So this means that this is the f composite g of x. What are f and g in correct order? So it's asking you about the original one, f and g. So here it's very easy. Let me try the first choice here. And instead of the x here, I'm gonna put all of the g. So it would be root 2x minus 1 plus 4. Yes, match my answer. Let me try the other here for you to understand. Instead of the x here, you're gonna put all of this. So it would be 2 times root x plus 4 minus 1. So it doesn't match. Here, instead of the x, you're gonna put 2x minus 1. So it would be 2x minus 1 plus 4. Again, it doesn't match. So the only choice here that matches my answer is A. If function of x equal 1 over x minus 4 and g of x equals the square root of x minus 1. So what is the domain of f composite g? Let's get the f composite g first. So instead of x here, I'm gonna put all of this. So 1 over root x minus 1 minus 4. At the beginning, root x minus 4, x minus 1 should be greater than or equal to 0. So that means that I'm gonna start from 1. So this means that x should be greater than or equal to 1. Okay, good. This is the first part. But don't forget that we have it in the denominator. So this means that the whole denominator should not be equal to 0. So here, x minus 1 minus 4 cannot be 0, right? So let me find the values that make the denominator equal to 0. So this one equal to 4. Now, this means that x minus 1 equal to 16. They squared both of them. So x equal 17. So I have to exclude this from the domain because this what makes the denominator equal to 0. Exclude. So here, x greater than or equal to 1, and x cannot be 17. Now, the inverse function, this is a very important topic, and you have a lot of questions on it on the SAT. So the inverse function means that you are reverse the function or undoing the function, okay? And as you see here, this is the function of x, okay? This is x and this is y. This is the domain and this is the range. What happens here in the inverse of x, function of x? We switched the domain and range. So this become again, you see here, this was the range, right? It becomes the domain of the inverse. And the domain of the function becomes the range of the inverse. So it's very important to know this, that we switch the domain and range when we get the inverse of the function. Now, how to find the inverse of the function from a graph or if you have an algebraic expression. If you have a graph, we have a test, we call it the horizontal line test. If your horizontal line test pass through the curve at more 1 point, so this means that you don't have an inverse, no inverse for this function. As you see here, 2 points. The inverse function is also a function, so it have to pass also with the vertical test. So as you see here, the inverse is not a function for this function, for the quadratic. What about this one? This is a cubic function, right? If you get it for the horizontal test, it passes only with 1 point. So yes, it has an inverse. So make sure that you understand that the inverse is also a function. So it has to pass with only 1 point, not more than this. So horizontal line test, if it passes by 1 point, so it has an inverse. It passes by more than 1 point, it doesn't have an inverse. Now, how to find it algebraically? Let me give you an example here to understand it. Here, function of x equal 5x minus 2. The first step, instead of function of x, you put y. So here, y equal 5x minus 2. Then you swap the x and y. You replace them. Let me write it for you with different colors to understand it more. Right, as you see here. So I'm gonna swap. So it would be x equal 5y minus 2. Then I have to solve for y. What is the meaning of solving for y? To isolate the y, to put it inside and all other variables or numbers in the other side. So this means I'm gonna transpose the 2 here. So 5y equal x plus 2. Still didn't isolate the y. I have to divide by 5. So y equal x plus 2 over 5. Yes, I get it. Now, instead of the y, I'm going to put the inverse of x. That's it. So I got the inverse of the function. I hope this is clear for you. Again, the inverse, we switch the domain and range. We have the horizontal line just to test the graph. Just only 1.2 has an inverse. How do we get the inverse function algebraically? First, you put instead of function of x, you put y. You swap the x and y, then solve for y. Which of the following graph does not have an inverse? Okay, so we have a test for this one. It's the horizontal test. Or horizontal line test. You draw a horizontal line if it passed by more than 1 point, so it doesn't have an inverse. As you see here, for this one, yes. So this does not have an inverse. But for this one, yes, it has. For this one, it has also. For this one, it has. So this is the only choice. What is the inverse of the function? Let me remind you, use the rule. Instead of function of x, you're gonna put y. Swap x and y. Now solve for y. So this means that y plus 1 equals 4 over x. Okay, how you got this? If I say cross multiplication, so x times y plus 1 equals 4. I need to isolate the y, so I'm going to divide by x. So this means that the y plus 1 equals 4. Okay, now I need to remove this part here. So y equals 4 over x minus 1. Where's the answer? Here's it. Function of x equals the square root of 2x plus 8. Then the domain of the inverse function. Okay, do you remember that? We have here function of x, and we have the inverse. For this one, you have the domain, and you have a range, right? We switch. If we have the inverse, you switch the range and the domain. So this means that the domain of the inverse function would be the range for the original function. Good. So I need to get the range now. The range for any square root function should be greater than 0 or greater than or equal to 0. So here is the answer. From 0 to infinity. You remember the square root function? It would be like this, starting from 0 to infinity. Nothing negative.